Your body isn't broken. It's just running code you were never given the manual for. Think about the last time you tried to fix yourself. Maybe it was a 16-hour fast. Maybe it was cutting carbs, waking up at 5 a.m., forcing yourself through a workout you hated. You did everything right, and 3 weeks later you felt exactly the same, maybe worse. Here's the part nobody talks about. That wasn't a willpower problem. It was a timing problem. Your cells don't care about your calendar. They care about signals. And most of us have been sending the wrong ones for years without knowing it. I know, that sounds strange. Stay with me because this changes everything. Right now, inside every cell in your body, there's a renovation crew on call, constantly, waiting for the signal to start clearing out damaged parts and rebuilding fresh ones. This process has a name, autophagy, and in 2016, a Japanese biologist named Yoshinori Osumi won the Nobel Prize for mapping out exactly how it works. Here's the critical thing to understand. Autophagy isn't a trend. It's not a hack. It's a switch your body has had for millions of years, and that switch only flips under very specific conditions. Most people never realize this. You've probably activated it by accident a handful of times in your life. During a stomach bug, a stressful week where you forgot to eat, a long flight with no food, and you probably felt strange afterward. Clearer, lighter, almost sharper. That wasn't random. Your body wasn't broken. It was protecting you. It was cleaning house the moment it got the chance. Here's where it gets counterintuitive. The renovation crew doesn't work off your motivation. It works off a chemical hormone inside every cell called mTOR. When mTOR is active, your body is in build and grow mode. Great for muscle, great after a big meal, but it physically blocks the cleanup crew from starting their shift. Growth and repair can't happen at the same time. Not in your body, not in any factory on Earth. And that's where everything changes, because there's a second switch, a sensor called AMPK, sitting quietly in your cells, constantly checking your energy levels, like a night manager walking the floor of the workshop, checking if the lights are still needed. When energy runs low, AMPK doesn't panic. It flips mTOR off, and the second mTOR goes quiet, the renovation crew clocks in. But here's what they didn't expect when researchers at the Salk Institute started mapping this timing more precisely. The window is smaller than anyone thought, and most people slam it shut before it even opens. Here's what changes everything. Every time you snack, sip a sugary latte, or just have a little something between meals, you spike insulin. And insulin is the loudest voice in the room. It screams at mTOR to switch back on him immediately. The cleanup crew drops their tools mid-shift. Every single time. That's the villain, not sugar itself, timing. It's not about eating less. It's about giving your cells enough uninterrupted quiet to finish the job they already know how to do. This was never your fault. Nobody taught you this in school. So here's the protocol, and every piece of it has a reason. Morning, delay your first meal by at least 90 minutes after waking. Black coffee or plain water only. Cortisol is naturally highest right now. That's your body's built-in energy boost. Eating too early blunts it and wastes the window. Midday, break your fast with protein and fiber first. Eggs, Greek yogurt, leafy greens, before any starch or sugar. This slows the insulin spike so mTOR doesn't flip on violently. Afternoon. This is your longest fed window. Eat real meals here. This is when growth signals should be active. Muscle repair, hormone production, all of it. Evening. Stop eating at least 3 hours before bed. NAD, a molecule your cells use to power the entire repair process, naturally rises overnight, but only if insulin has dropped first. Late eating cancels the renovation shift before it can start. Sleep. This is where autophagy peaks. Not during your fast. During deep sleep layered on top of it. Here's the part that matters. None of these steps work in isolation. They stack. A slightly longer morning window makes your afternoon meals more effective. Better afternoon eating makes your evening cutoff easier. Easier evenings mean deeper sleep. Deeper sleep means more repair. It compounds, quietly, invisibly, night after night, until one day you notice you feel like a different person. Your body was never against you. It was just waiting for the right instructions. And there's one more switch we haven't touched yet. One tied directly to your telomeres, the protective caps on your DNA, and the Nobel-winning discovery that changed how scientists think about aging itself. Your DNA has a built-in expiration date, unless you do this. Every time your cells divide, something inside you gets a little shorter. Not your muscles, not your metabolism. Something smaller, something you've never seen and were never told about. It's called a telomere, and for most of your life, it's been quietly counting down. Here's the part nobody talks about. You've probably heard aging is in your genes and assumed that meant your fate was fixed the day you were born. That's not quite true, and the truth is stranger and more hopeful than the myth. I know, that sounds strange. Stay with me, because this changes everything. Picture your DNA as a long shoelace, packed tightly into every one of your cells. Every time a cell divides, which happens billions of times over your life, that shoelace gets copied. But the copying machine has a flaw. It can't quite finish the very tip of the lace. So each time, a tiny bit gets left behind. That's where telomeres come in. They're the plastic caps on the end of the lace, protective, disposable, built to absorb the damage so the important part, the actual genetic code, stays intact. Here's the critical thing to understand. In 2009, a biologist named Elizabeth Blackburn won the Nobel Prize for discovering not just that these caps exist, but that their length is directly tied to how your cells age. Short caps, and the shoelace starts fraying. The cell can't divide safely anymore. It either shuts down or starts malfunctioning. Most people never realize this. Aging, at the cellular level, isn't really about time. It's about how many times your cells have had to divide and how fast their protective caps have worn down. And that's where everything changes, because Blackburn's team found something else. Something the textbooks hadn't caught up to yet. Telomere length isn't fixed. It's not just genetic. It responds to how you live, every single day. Here's where it gets counterintuitive. Chronic stress wears telomeres down faster. Not stress itself, the hormone it triggers. Cortisol, running high for months at a time, has been shown to accelerate this shortening. Your body starts spending its protective caps just trying to survive the week. But here's what they didn't expect. There's an enzyme, telomerase, that can actually rebuild these caps, slowly, quietly, like a maintenance crew rethreading the tip of the lace before it frays completely. Part 2, Kaelia, next type, Karain. Here's what changes everything. Telomerase isn't rare. It's not locked away. It's sitting dormant in your cells right now, waiting for the right conditions to activate. That's the villain, if there is one. Not aging. Dormancy. This was never your fault. Nobody taught you how to switch it on. So here's the protocol, and every piece of it has a reason. Morning, get sunlight within 30 minutes of waking, even 5 minutes on a balcony. This anchors your cortisol rhythm early, so it drops properly by evening instead of staying elevated all day. Midday, move your body. Walking counts. Studies on telomerase activity have linked consistent moderate movement, not extreme exercise, to longer telomere length over time. Overtraining does the opposite. It spikes cortisol right back up. Afternoon, protect your relationships and your recovery time here. Chronic isolation and unresolved stress are two of the strongest predictors of accelerated telomere shortening in long-term studies. This isn't soft advice, it's biology. Evening, wind down without screens for the last 30 minutes before bed. Blue light delays melatonin, and melatonin isn't just for sleep. It's a powerful antioxidant that protects your DNA from the very damage that erodes these caps. Sleep. This is where telomerase gets its best working conditions. Deep, uninterrupted sleep is when cellular repair, including this rebuilding process, runs most efficiently. Here's the part that matters. None of these steps work alone. Stack the sunlight with the movement. Stack the movement with the connection. Stack the connection with the sleep. It compounds, quietly, invisibly, until the cap at the end of your DNA is a little longer than it would have been. Your body was never counting down against you. It was just waiting for you to give it a reason to keep rebuilding. And there's one more piece we haven't touched. A molecule your cells burn through faster after 40. One that both autophagy and telomerase depend on to function at all. The one molecule your cells can't repair anything without. By the time you turn 40, something inside you has already dropped by half. Not your metabolism, not your hormones. Something more basic than that. Something every single repair process in your body depends on to function at all. And almost nobody has ever told you its name. Here's the part nobody talks about. Remember the renovation crew inside your cells? The one that clears out damage during autophagy? Remember the maintenance crew rethreading your telomeres, keeping your DNA intact? Neither of them can work without power. I know, that sounds strange. Stay with me because this changes everything. Picture your cells as a workshop running 24 hours a day. The renovation crew, the maintenance crew, every repair job happening inside you right now, none of it runs on willpower. It runs on electricity. And the molecule that carries that electricity from one process to the next is called NAD+. Here's the critical thing to understand. NAD isn't a supplement trend. It's one of the oldest molecules in biology, found in nearly every living cell on Earth. Without it, your mitochondria can't produce energy. Without it, the enzymes behind autophagy and telomerase simply sit there, powerless, no matter how well you've timed your fasting or your sleep. Most people never realize this. You could do everything right, the fasting window, the sunlight, the movement, and still get diminishing results, because the crew showed up. But the power was low. That wasn't a discipline problem. Your body wasn't refusing to repair itself. It was running out of fuel to do it with. Here's where it gets counterintuitive. NAD+ levels don't decline because you did something wrong. They decline because of basic biological math. Every repair job spends a little NAD and never gets it back in full. By 40, researchers have found levels can fall by roughly half compared to your 20s, by 60%, even further. And that's where everything changes. Because scientists at Harvard, studying a family of proteins called sirtuins, found that these are the exact enzymes responsible for activating both autophagy and telomere maintenance, and every one of them runs directly on NAD. No NAD, no sirtuin activity. No sirtuin activity, no renovation, no maintenance, no matter how perfect your timing was. But here's what they didn't expect. The decline isn't just about age. It's about how fast you're burning through your supply. And something is quietly draining it faster than biology alone ever would. Part 2 Kaliye, next type, Karain. Here's what changes everything. There's an enzyme called CD38 that activates during chronic inflammation, poor sleep, constant stress, a diet high in processed sugar, and it consumes NAD aggressively, almost like a leak in the power line. That's the villain, not aging itself, the leak. This was never your fault. Nobody taught you your cells could be quietly bleeding fuel. So here's the protocol, and every piece of it has a reason. Morning, after your fasting window opens, include foods naturally rich in NAD precursors, tryptophan-rich eggs or fish, and a serving of leafy greens. This feeds the raw material your body converts into new NAD+ over the following hours. Midday, keep blood sugar steady rather than spiking it. Sharp glucose spikes drive inflammation, and inflammation is what switches CD38 on in the first place. Stable meals mean less of your NAD gets siphoned off before it's even used. Afternoon, this is a good window for moderate exercise. Movement has been shown to boost NAD production directly inside muscle cells, essentially opening a second power line alongside your diet. Evening, minimize alcohol, especially close to bedtime. Your liver prioritizes breaking it down using NAD, pulling fuel away from the repair processes that are supposed to run overnight. Sleep. This is where NAD regeneration and cellular repair finally sync up, but only if the leak has been controlled during the day. Here's the part that matters. None of these steps work in isolation. Steady blood sugar reduces the leak. A smaller leak means more fuel reaches your evening repair window. More fuel means autophagy and telomere maintenance can actually finish the job. It compounds quietly and visibly. Every single day you keep the power line intact. Your body was never out of ideas. It was just running low on the one thing every repair depends on. And there's a fourth piece we still haven't touched. A hormone that decides every single night whether any of this repair work gets greenlit at all.